So today we will be discussing about what device drivers are. Okay. So in consideration to the laptop that you are using, you have many devices that is connected across. Say you have your Bluetooth module, you have Ethernet, wireless LAN, you have the webcam, all these. Then you have your graphics card that is integrated. You have Intel graphics card, you have NVIDIA graphics card, audio driver, all sorts of display. So all these are actually integrated or interfaced to your motherboard. Okay, so to drive all these, there is a hardware part and there is a software part. Like when you study more deep into the embedded system, you will see that these embedded devices, they are designed in such a way that you have a software design going in parallel and also you have a hardware design going in parallel. Okay, so most of the devices, they won't be active unless and until the software is running. So that is why when you install a device, that device will not be detected unless and until you install the driver. So you plug in your USB, automatically there is a the driver of the device. You can see the device is getting installed, and after that only your USB will be displayed. Okay, so there are softwares or functions which is carried out by the operating system, which installs or which enables access to these hardware, which integrates the hardware, maps it to the external memory addresses, so that the devices can work properly. So those type of softwares are known as device drivers. Okay, so device driver is a small piece of software that tells the operating system and other software how to communicate with the hardware. Okay, so so before that, I will show you something. Okay, so yeah, so this is how your you might have seen the Windows operating system. You have a graphical user interface. You click on the executable software and you install the file. Okay, but there is a shell-like structure to this system. Okay, that is the overall operating system is what you see, but inside that there is a application software layer, there is a system software layer, you have a device driver. This hardware layer is not directly in connection with us. Okay, what we do, we actually install the application software or the device driver. It is the device driver which communicates to the hardware. Okay, so there is something known as a kernel in the operating system who does the device management, memory management, and all sorts of functions. Okay, so the operating system as a whole gives you a package in such a way that there is a user interface in which we are interacting or the user is interacting. Okay, so these are the different layers. Now, with the help of device drivers, we are able to interface and control the hardware. Okay, so this you can take it as a software library that helps to initialize the hardware and manage higher layers of software. Okay, by accessing the hardware. Okay, now what all does a device driver have? It has routines. Okay, routines in the sense, see, when you wrote a 8085 program or 8051 program, you might be using the instruction call instruction. So they are known as subroutines. Okay, they are nothing but they are, like in your high level language program, you will be writing functions same way. Okay, so these are functions related to that particular hardware, but that is accessed by a high level language programmer. Okay, and it does the interaction with the device hardware. It sends control commands to the device and communicates data to the device. And also it runs the codes for reading device data. So that is how the device driver gets installed and you get all these access permissions and you're able to use that hardware. So it is actually the device driver is considered as the software layer between the application program and the device. Okay. Now, you have two types of device drivers based on how or where they find their use. Okay, so they are known as architecture specific or generic. Okay, this generic term you might have come across while you downloaded device drivers for your laptop. Okay, so first one is architecture specific. See, you can manufacture controllers with its own integrated memory, then hardware. Okay, RAM, ROM, all these things. Okay, so for that you require device drivers which is architecture specific. Okay, that is because the hardware is integrated on the master processor. Okay, so say the examples are on chip memory, integrated memory managers, that is the MMUs. In the current generation of processors or in your new generation phones, you have MMUs. MMUs are dedicated units for managing the memory. Okay, for managing the memory. So they do all the memory related operations. Say for example, translating your logical address into physical address. Okay. Now, what is a physical address is, okay, say for example, when you have your 8086, in 8086 the address is 20-bit, but the registers are 16-bit. So naturally, you cannot represent the 20-bit address in a 16-bit register. So they translate it into a logical address and offset address, which are 16-bit each. And when we convert it into a physical address, it is generated to 20-bit address. So that translation and things of such is done by the memory management unit. Okay. Now, talking about the generic type of device drivers, these are device drivers created for managing the hardware that is located on the board. Okay, that is which is integrated with the processor on the board. Okay, external to the processor. So these are not specific to a processor. Okay, so examples are like the I2C, PCI, then level 2 cache, flash, your Ethernet, your display driver, mouse, all these are generic type. See, when you might have installed these drivers or when you went to download, you would have seen the word generic drivers. Okay, so when you talk about these onboard bus device drivers, okay. You have an onboard bus in which you have the data bus and the address bus. So what is associated? What type of what is the protocol or what is the function that is associated with onboard device drivers? So there are these three things. Okay. So first one is known as arbitration. Arbitration in the sense some type of protocol. There is some type of protocol that is defined which shows you how a device can gain access to the bus. Okay. Also, when we discussed your DMA, we have discussed the term handshaking. Okay, handshaking is like you request a person for something and he acknowledges it. So that is known as a handshaking. So there are rules attached that the device must follow to communicate over the bus, because the bus may be used by someone else. Okay. And also, there are signals associated with various bus lines. Say, for example, if it is an I/O operation, you have I/O read and I/O write. If it's a memory operation, you have memory read and memory write. Similar like that signals. Okay. So mainly there are 10 functions which we will be seeing in the next slide. So bus protocol is supported by the bus device drivers, which includes a combination of all the functions which we are going to see. Okay, so these are the functions. Now, almost all these functions are associated with any type of hardware. Okay, so bus startup in the sense when a device is turned on, the initialization of the bus, on, power on, or reset. Then shut down. When the system is shut down or the device is shut down, what configuration the bus has to go. Then bus disable, allowing other softwares to disable the bus on the run. Okay. Bus enable means allowing the softwares to enable bus. Okay. Acquire in the sense you are gaining access to the bus. Okay. So that is a locking mechanism. Once a person or once a device gets access to the bus, say you have seen in the direct memory access when DMA request the CPU to get control of the bus. Okay. So once the DMA controller gets it, the bus, only after it is released, the CPU will be able to access the bus. Otherwise, the CPU will be doing operations which do not require using the bus, or it may remain idle. Okay, and bus release, once that particular software completes its operation, it releases the bus so that other softwares can use it. Okay, bus read, allowing the software to read data from the bus. Write, allowing the software to write data. Okay, then install bus, allowing other softwares to install the new bus device. Okay, and uninstalling means remove that software. Okay, so remove installed bus device. Okay, then this comes while we install a device driver. This is it is associated with the memory. Say like when you install a software or when you install a driver, there are certain data which has to be mapped means saved onto the memory. Okay, because whenever a device runs, that data has to be loaded, and then only the hardware will work accordingly to that particular pointed data. So allowing the device software to be pointed to an address is known as mapping. Okay, so once these are done, then only the proper working of the hardware will be happening. Okay, so that is known as mapping. Now unmapping is remove, say like when you disable, when you deactivate that particular device, all the data that is associated with that particular device will be removed from that hardware storage device. Okay, so that is unmapping. Now there are certain states in which the device or the hardware goes into. First one is the inactive state, where either the device does not have any power or it is disconnected, or it can be disabled. Okay, when you go to your device manager, you can see disable, uh, uninstall, all these. So when it is uninstalled, that is the inactive state, or when it is disabled, that is the inactive state. Okay, so it won't be running in the background. Next is the busy state. Busy state when it is already accessed by some other software or hardware. It cannot be used by any other device. Otherwise, there might be cache coherence problem or some data coherence problem. Okay, so once one device is using, it will be in the busy state. Okay, so it should be released. Then only it can be accessed by another device. So the next state is finished state. Finished state is in the sense that a software has completed the access on that particular device, and it is waiting for another device to use it. Okay, so it will be in idle state. So allows acquisition, read or write request at that particular time. So these are the different states of devices. Now, what are the commands that a device driver can have, which a programmer uses? Usually generic commands. Now, these are create, open, connect, bind, read, write, IO control, delete, and close. Okay, so these are the commands. Then now these there are device drivers for interrupt handling also. So what are the functions of device driver to handle interrupts? Are interrupt handling, startup, interrupt handling shutdown, interrupt handling disable, interrupt handling enable, and servicing. Okay, so what it does is whenever an interrupt occurs, the initialization of the interrupt hardware is the startup. When the shutdown occurs, the same thing what we discussed for bus related functions, that same meaning applies here. Okay, only thing is it is with interrupt driver. So disable in the sense it disables other softwares which is accessing it. Okay, enables, it allows other software to enable the inactive interrupts. Okay, so next is What is the criteria based on how the startup, shutdown, disable, enable, and service functions are implemented? Okay, first one, always the interrupts will be having a priority. Or in 8051, you might have seen there is an instruction known as INT, and INT is associated with a number 0 to 255 you have. So there are different types. There is a number and the priority levels of interrupts that is available. Okay, always the priority is from ranging from 0 to n, where the least number has the highest priority. Okay, so that is the way in which priority varies. Okay, then how these interrupts are triggered. Okay, whether it is hardware interrupt or whether it is software interrupt. Then the interrupt policies of components within the system that triggers the interrupt. Okay, these components also, they have certain policies as to how they react to different interrupts. Then the services provided by the master, that is the main CPU which is processing the interrupt. Okay, so these are the criteria in which all these 5. Okay, context switching is another. It is actually a very important topic which we need to have discussed while we. I think we have discussed in a short note about what a switching is, but I did not use the term. I think so. Context. Now, context switching is very important in terms of when you talk about interrupts or when you have a task running and there is a high priority task coming or an interrupt coming. At that time, your processor has to stop the current execution and go for executing the interrupt or the high priority task. Okay, say you might be familiar with the term critical section. Okay, so now context switching is nothing but say whenever an instruction is executed, you might have seen in your 8051 simulation there are values in each registers which are changing. Okay, the values in the PSW is changing. So for each instruction execution, there is a value associated with that. So imagine that at that particular time, a hardware interrupt has occurred. So what a hardware or a high priority interrupt has occurred. So naturally, what happens? You have to stop that instruction. You have to go back you have to go to execute that interrupt that has happened, and then you have to come back and resume. So when you have to come back and resume, you need to have the data where we had stopped. So that is the term where context comes in. So context is actually a data structure in which you have the registers value, the current address which the program counter is pointing to. Okay, and the data of the flag, the data of the stack, all these things. Okay, so these data, when you have an interrupt to be executed, the current instruction is stopped and all these data will be saved. So that is a data structure, that is a group of data. Okay, so that is saved to a point in stack. Okay, that is saved to a point in stack and it is saved there while the CPU goes to execute the interrupt service routine. So the steps involved are: first, the current execution is stopped, then it saves the context, okay, onto a stack or a dedicated location in the memory. Okay, and then once the master processor or the CPU completes the execution of the interrupt service routine, it comes back and retrieves that context that is saved in the stack area because it needs to resume. Okay, always returning from an interrupt will be encountered by a RET instruction or RET-I instruction. Okay, so that context is loaded back. All the registers, all the stack, the program counter, everything is loaded back with its initial value of the main program, and the execution is begins or resumes. Okay, and the main program is executed back again. Okay, so that is what context switching is about. Now, the same way you have memories associated. So each of the memory, you have your RAM, you have your ROM, all these things. So once they are installed, they also have their own device drivers. Now, the software involved in manages the memory on the master processor and also on the board, as well as it manages the memory hardware mechanism. Okay, so this memory subsystem system means it includes all the memory management components, say like your memory controllers or your memory management unit, And also, the different types of memory that you have, such as your registers, the cache, the ROM, the DRAM. Okay. So same way as we discussed, we have a startup, we have a shutdown, we have disable, we have enable. Okay. Which does the same function as we have discussed before. Okay. And extra you have, because it's a memory, you have a read operation and you have a write operation. Okay. So this is the topic covering the device drivers. Thank you so much.